In this tutorial, you will learn how to jog a robot efficiently in iiQWorks.Sim and understand how these movements translate into your program that will later run on with iKUKA OS 2 using a real or virtual robot controller. We will focus on three essential jogging methods: axis-specific jogging, Cartesian jogging, and snap-based positioning. Open a layout with a KUKA robot and select it. Then navigate to the Program tab. On the right side on the simulation, you should find a new window called Jog Panel where you can see the different axes of the robot. First, make sure the manipulation mode is set to jog. This is important because you want to move the robot itself, not the object in the 3D scene. Now reset the simulation to ensure a defined starting point. We start with axis-specific jogging. Each joint of the robot can be moved individually. Simply select one axis and drag it to rotate the joint. You will notice that the corresponding slider in the jog panel follows your movement. Alternatively, you can use the slider directly or enter a precise numerical value. The robot will immediately move to the defined position. If you want to return the robot to its original state, click the reset button at the top of the simulation window. Next, let's look at Cartesian jogging. Here, you control the robot in Cartesian space using arrows and rotation handles. Dragging an arrow moves the robot along a specific direction, such as X, Y, or Z. You will notice different step sizes depending on your cursor position. Larger steps, such as 250 mm, are used when you drag further away from the center, while smaller and more precise steps, such as 100 mm, are available closer to the axis. You can also rotate the robot flange using the circular handles. This allows you to adjust the orientation of the tool center point, also known as the TCP. Additionally, there are planar movement handles. These allow you to move the robot within a plane without changing its orientation. Now let's explore coordinate systems, which are essential for precise control. By default, you are working in the world coordinate system. This means all movements follow the global X, Y, and Z directions. If you rotate the robot and switch to parent mode, the coordinate system will align with the robot base. This is useful when you want to move relative to the robot's mounting or bases. In object mode, the coordinate system is aligned with the tool center point. This allows intuitive movement based on the tool orientation, which is especially helpful for tasks like welding or picking. You can switch between these coordinate systems at any time depending on your task. Another efficient method is snap-based jogging. Activate the snap function using the violet circular handle or the snap button. Then click on any object in the scene. The robot will automatically move its flange to the selected position. This is particularly useful for quickly defining target positions during offline programming. In addition to the violet circular handle, you can use the snap button in the menu bar to select specific snapping methods. You can select the one-point method, the two-point midpoint method, or the three-point arc center method. In addition to that, you can select if the position or the orientation should stay the same during snapping. With the snap type, you can select to what 3D information the target location should be snapped. Finally, you can define a custom start position for your simulation. Move the robot into the desired position, then go to Settings and select Save State. From now on, every time you reset the simulation, the robot will return to the saved position. This is extremely useful when validating repeatable processes in your offline programming setup. Once you are satisfied with your robot movements in iiQWorks.Sim, you can proceed to adding points in the programming window. We will cover this topic in a later video. You now have a solid foundation for jogging a robot efficiently and snapping the TCP to objects in the simulation. Thank you for watching, and enjoy working with your robot simulation.
Thank you for watching. We hope you find this video tutorial helpful. Don't forget to follow the KUKA channel for more updates and more exciting content. If you're looking for hands-on training, visit the KUKA College to enhance your skills. See you in the next video.
Making automation easier.